in today's session, we are going to discuss two important aspects. One is what are the different ways of reading a input in a Java. So that is the first aspect. Now, this is not a part of your syllabus, but this is an important concept which we need to understand. This is the one aspect. And the second aspect is this is a lab session, so we have to discuss one lab program also. Clear? So let us not waste much of a time because we have to discuss so many things, have a better energy and a better concentration. Right. So reading the input in a Java. So first and foremost, we need to remember that everything is object with respect to Java. Why I'm saying this particular point here is, see, if you are going with the C language, you have only one function for reading a input, right? So you will be using a scanf, correct? If you are going with a C++, there also you have only one particular function which performs a reading input. So that is cin. If anybody don't know C++, no problem. But what I mean to say is, with respect to C or a C++, you have a one particular function for a reading input, correct? But why there are more than one number of ways of reading input with respect to Java? Because in a Java, everything will be considered as an object. When you are saying something as an object, there comes some versatile things. Versatile things in the sense, you will be working with so many different types of data types, right? You will be working with so many different types of data. I mean to say, you will be working with the images, doc files, normal text files, all those things, right? So what has been done is, when it is an object, you have so many options with respect to object, right? So as you have so many options with respect to object, in the same way you have a different ways of reading an input also, right? Clear? With respect to that means with respect to reading an input in Java, there are so many different ways, but most commonly used are these four ways. I will display you what are those four ways. First one is by taking values from the command line arguments. This is first approach. Second approach is hard code in a program. That means within a program itself, you will initialize some value, say int a is equal to some 10, int b is equal to some 20, something like that. Third one is by using a scanner object. That means you will be creating object of a scanner. Then by using a scanner object, you will be reading an input. We will discuss in detail how exactly that particular scanner object will work. You have one more category, that is a fourth way. This is by using a buffered reader, right? So there is something called as a buffered reader. I will explain you what exactly is a buffered reader and how it is different from your scanner. Okay, so these are the four most commonly used ways for reading an input from the means reading an input in a Java from the user perspective. That means whatever a user enters, so that particular input will be read either of these ways. Clear? Right. So most of you might have already know what exactly is a command line argument and how to read that particular information, right? So working with the command line arguments. So with respect to command line arguments, input is given during the runtime of a program through command line, right? So here is a simple example. So I already told you why this particular argument string args has been written. So whatever compile time, so means whatever command line arguments you are going to give, all those command line arguments will be stored in array called args. This we have said in many examples, and we have seen a few examples on this particular aspect also, right? So when you are using the command line arguments, you need to make sure that compilation you don't give any values, just compile it properly. So but when you are running a program, so this is a Java input demo dot something, right? So when you are running a program, don't forget to give a command line argument, right? So whatever argument you are going to give here, so this particular argument will be stored in a args, right? So later I'm just printing whatever is the content of args, I'm copying into string yes, and I'm just printing that particular string yes, right? So here if you want to give a more than one number of strings, that means more than one name, so you can just give here during the runtime just by specifying some space here, right? So Thor space Rancok space Captain American, whatever the things you want to give, So it can be given. So all these values, whatever the command line arguments you are going to give, everything will be stored in this particular array called a ARGS. Hope no doubts with respect to reading the values from a command line.
No, sir.
Yes. So the next category is initializing a variables by writing a hard code. So in a hard code, we will be creating a variable. After creating a variable, then and there itself, whatever a suitable value with respect to that particular variable, you are going to initialize with respect to that. Right. So this is what we have practiced from the starting of our Java classes. Clear? Yes. The third category is using a scanner object. Right. Here we need to remember one important part. With respect to scanner in the sense you wanted to scan something, right? When you want to scan something, then the system will ask you from where you want to scan, right? Whether you want to scan from a keyboard, whether you want to scan from a mouse, whether you want to scan from some scanner, barcode readers and all those things, right? From which particular input you wanted to scan actually, right? So this is what the question will be asked with respect to scanner. And the scanners have been introduced from a version 6 onwards. From a Java version 6 onwards, you have a scanner, right? So before to that versions, how they were reading an input, that they were using buffered reader, right? We will discuss what exactly is a buffered reader later. Clear? Scanner object will always ask from where it has to read an input, right? So you need to specify from where you wanted to read the input, right? So that is the reason, if you remembered in early programs, you have written scanner SSE is equal to new scanner of. In the bracket, you were supposed to give something like a system.in, right? So what does the system.in says? So that is your standard input, correct? So standard input, where it will be pointing now, system.in, in the sense your system.input will be pointing to what is called as keyboard, right? Say for example, if you want to read from some file, that means you need to create an object of a file. So instead of writing a system.in, you need to give an object of that particular file. We are not going to see those kind of examples because we are not dealing with the file handling. We have that particular file handling thing in our fifth module. So that time we will use a scanner object for reading a file input also. Right. So let us see the points with respect to scanner. Then we will see one example using a scanner. Right. So scanner is a class in java.util package used for obtaining the input of the primitive types like int, double, etc. and strings, right? So int, double, short, all those things. Along with that, it will be used for reading the strings also. Okay. And one important thing you need to remember with respect to scanner is, whenever, so means with respect to Java, we say everything as an object itself. But when you are using a scanner, it will be having a capability, whatever input you are going to give, it will think, so means it can scan what type of a data you are giving, right? So what I mean to say is, if you are giving an int, it will check whether you have given a proper int or not. If you are giving a float, it will check whether you are giving a proper floating point value or not, right? So the name scanner has come just because whatever input you are giving, so that it will scan. That means it will analyze what kind of a data you are giving, right? Let us see a few more points. It is the easiest way to read an input in a Java program, though not very efficient if you want an input method for scenarios where time is a constraint. That means if you are writing a program where you want to analyze some time complexities and all, right? If you want to analyze the performance of your some algorithm, so in those scenarios, this is not recommended because it will take some time for this one, right? So there is some concept called a synchronized, not synchronized, and all those things. This scanner class is not synchronized in the sense It cannot be used with respect to thread concepts. That means multi-threading and all multi-processing kind of a stuff. Your scanner object, that means this particular scanner class cannot be used. That means there is a performance bottleneck with respect to scanner, right? Wherever you have a time constraints with respect to program, don't go with the scanner one, right? So if not a scanner, then what is the option? You have something called as buffered reader. Clear? Done. To create an object of a scanner class, we usually pass the predefined object, which is system.in, which represents the standard input to stream, right? We may pass an object of a class file if we want to read an input from a file, right? So I already told you, whenever you are creating a scanner object, it is your responsibility to tell that particular scanner from where it has to read the input, right? If you are writing a system.in, then you have specified that you wanted to read an input from the keyboard. Clear with the things? Yes. To read a numerical values of a certain data types, some XYZ, the function to use is next followed by XYZ. That means next int, next float, next double, right? So next line, right? So whatever is the data type, XYZ data type, you have to use, you will be using a name called a next followed by that particular data type. For example, to read a value of a type short, we use next short, right? So similarly, if you want to read a int, you will be using a next followed by int, right? So all these methods that are declared with respect to your scanner class only, right? So once you say scanner SSC is equal to new scanner, that means you are creating object of a scanner, right? So when you are creating object of a scanner, so using that particular object, you are able to invoke all these methods. That means these particular methods belong to that particular scanner class itself. Clear? And all these methods will return the same data type, whatever the XYZ type is. That means if you are writing a next short, right? If you are using a object dot next short, the return type of this particular method will be short itself, right? If you are writing object dot next int, right? So the return type of that particular method will be a again int itself, right? If you are writing object dot next double, the return type of that particular method will be a double itself. Clear with the things? This is the only reason why I have not taken this particular reading input in a Java in earlier, I mean in the starting of classes, because now if I say something with respect to object and a method, you can get some imagination. That time when you don't know what is a class, what is the object, if I keep on telling all these things, how you can relate the stuff, right? Hope things are clear till this point.
Yes, sir.
Yes. To read a string, we use next line. So there is a method with respect to reading a string. So you will be using next line, not a next string. You will be using next line. Okay. If you want to read a character, that means you have a given one particular string. So from that particular string, you wanted to read a first character. See, what we are discussing is we are discussing different data types, how to read a different data types, right? If it is an int, float, double, all those things can be just read by next followed by double, next followed by int, next followed by short, right? So the problem comes with respect to string and a caret, that means character. So with respect to string, you cannot, so means you don't have a method called a next string, right? So instead of a next string, you have a something called as next line. That is a one thing. You don't have a method called a next char. What you have is you need to write a next method, right? So whenever you say next method, it will read a string. From that particular string, you need to specify dot caret of a 0. That means whatever is a character at a location 0, so that will be read from this particular string, whatever you are reading. Clear? Yes. So here is a small example which explains how that particular, so means a scanner object can be used. right? So nothing new has been done. Whenever you are using a scanner, you will be writing a import java.util.scanner. This is a class which need to be imported. If you don't remember, means if a scanner is lengthy for you, you can write a java.util.star also. So all the classes with respect to that particular package will be imported. Now, so creating a scanner object, scanner s is equal to new scanner. So I already told you, you will be specifying a system.in because you wanted to point your scanner object to the keyboard, right? So next line will be reading a integer value. So next dot char at will be reading a character, one particular character. So then similarly for a byte and all you can use. So next int, right? So next int will read a integer. Similarly next long will read a some long value. So next double will read a some double value, right? So just input statements have been given. So whatever has been read from the user, so the same thing has been printed using a system.out.println statements. Program is a simple, but in the same program we have taken different types of data to be read. So it is looking like a bigger one. I'm displaying a program just because in the previous classes we have seen you have written that particular statement, scanner s is equal to new scanner. So can we proceed?
Yes, sir.
Yes. Okay. So the next thing what we need to discuss is your buffered reader. Okay, I made animations for this. Okay. Buffered reader is also used for reading a input from the user, but the thing is this particular buffered reader, whatever input it reads, everything will be a string itself, right? So what I mean to say is even if it reads an integer, that means this particular buffered reader has got a one method which is called as a read line, right? So only one method is there with respect to buffered reader. So this particular method is common for all the different data types. What happens is even if it reads an integer, that particular integer will be considered as a string itself. After reading that particular input, you have to convert that particular input to an integer explicitly, right? Before we see example of this particular buffer reader, let me tell you a small example. I'll show you a small example how exactly the buffer reader will look at the data. Okay, 1 second. Right. So let me remove these statements. Okay. With respect to buffered reader, we have to remember few points. Point number one, here also you have to tell from where you need to read a data, right? If you want to read from a keyboard, so obviously this will be system.in. This we have seen even with respect to scanner class also. This is first point. Then whatever input is read, from a system.in, this particular information, this particular data will be in a byte format, right? So whichever values you will be specifying, so those values will be converted into a byte. So read in the terms of a bytes. Now the thing is your buffered reader won't understand this particular byte information, right? So what it understands is it understands what is called as character stream. What a buffer reader understands is character stream. So there should be some intermediate object or intermediate person who converts this particular byte read information to character stream, right? So why this buffer reader is reading an input in a character stream? Why can't it takes a directly byte? Reason is, if it is manipulating a data, if it is managing a data in terms of a character stream, then operations will be a faster, right? When compared to a processing in terms of a bytes, it will be a slower, and a processing in terms of a character sequence, it will be a faster. And most of the times, this particular buffer reader will be used only with respect to strings. Clear with these 3 points? First, you have to mention from where it has to read. So you will be writing system.in. Second, your buffer reader will be expecting a data in a character stream, but with respect to system.in, you will be entering a information in a byte stream format, right? So there should be some intermediate person who will convert this particular byte stream to a character stream, right? So who is that intermediate person? I forgot to remove this. Okay. Who is that intermediate person who will perform this particular conversion from a byte stream to a character stream, right? So you have something called input stream reader, right? So there is some class which is called as the input to stream reader, which converts your byte information into character sequence. Clear?
Yes.
Means clear with these 3 points means then I will try to convert these statements into the program, because we need to relate the concepts, then only it will be easy for you to remember the statements why we are writing those statements. Right. So now let us say I wanted to read a string from the user. Initially, I'll make it as a null. Now, my intention is, by using a buffered reader class, I'll be reading the input from the user. First and the foremost thing is, whenever you are using a buffered reader, you have to import a package called java.io, right? So once you have imported that particular package, in a IO package, you will be having something called as buffered reader, right? So now the thing is, we have to work with buffered reader now. So let us create object of buffered reader, right? So buffered reader br is equal to new buffered reader, right? So what I said is, this particular buffered reader will be reading information, will be expecting a information in a character stream, but whatever input you are going to get, so that will not be in a character stream, that will be in a byte stream, correct? Now what has to be done? What has to be done is, you need to have something called as input stream reader, right? I will write it as something like a ins input stream, which is equal to new input stream reader. Method has been created. Now I will say this particular buffered reader should take input from this particular ins. Clear with the things? Now, for this particular input to stream reader, you can, that means you need to specify from where it has to read the input, right? From where this particular ins need to read the input. So for this, I will say you read the input from system.in. Right? I will tell the input stream reader to read an input from a system.in, right? So later, whatever it has read, right, it will be reading information in a byte format. It will be reading information in a byte stream format, right? So now that particular byte stream format, once I say new is equal to, right? So here, so this will be taken it as character stream, and this particular character stream will be given to my buffer reader, right? So now with respect to buffer reader, I can write read line method, so which will read whatever the line you are giving from a command prompt, that one let me assign to yes. Now I can write system dot out dot println of whatever is read with respect to yes. Let me just cross check whether things are going to work fine or not. Later we will see. Can we reduce few instructions? Java C dot Java. What it is saying? Unreported exception, IO exception, must be caught or declared to be thrown. Right? So with respect to which statement it is saying? It is saying with respect to br.readline. That means as you are using the content, as you are using the IO package, in IO package you said you will be having a class with respect to a buffered reader, right? So now what it is saying is this is checked exception kind of a stuff. Whenever you are using a buffered reader, there might be a possibility of IO exception, right? So what it is saying is you have to include this particular statement in a try catch block or need to be thrown, right? So what is the solution for us? We need to say that yes, I know that if I am using a buffered reader, there will be IO exception. I don't want to write anything with respect to catch, so just I will not write a try catch block. I'll just specify throws followed by whatever is the expected exception, right? So let me try to check once, will there be any errors further? Not. Compiled fine. Oh, sorry. Expecting some input, let me say some input, so that particular input has been printed. Clear with each and every statement, point, instruction, whatever we have written.
Yes, sir.
Why we are writing import statement? You should have a clarity. Why we are writing a throws IO exception? You should have a clarity. Why first we have declared input stream reader and pointing that one to a system.in. So this particular statement, so it will convert your byte value into a character string. So that particular character stream you are giving to your buffered reader. So once a buffered reader object has been created using a buffered reader object, you can call a method called a readline. So that particular string value will be read into a whichever variable you have assigned. If you don't have a questions, means if you are clear with the stuff, then it is fine. If you don't have a question, then I will try to modify a few statements. Process will be the same, but way of writing will be slightly different. Shall I do the modification? Yes. Modification means a simple thing. I don't wanted to write as these two statements in a separate lines. What I wanted to do is I wanted to just combine these two things, right? How to combine these two things, right? Okay. So what I will do is instead of writing ins is nothing but object of an input stream reader, right? Now what I will do is I will not write ins, rather here only I will create this particular object. Can't it be done? Yes. For this particular input stream reader, here only I will specify that you read an input from a system.in. Correct. Now I don't require this statement. Analyze the statement from right to left. That means from this point to this point. Now what you have done? System.in is nothing but pointing to your keyboard, right? So what type of a data it will read? It will read byte information. That byte information read will be given to a input stream reader object. What this input stream reader object will do? This will convert to a character stream. So that will be given to a buffer reader, and your object will be pointing to that particular buffer reader. That means that particular uh, keyboard, right? So now BR will be pointing to your keyboard, and it will be ready to read the values with respect to a character string. Shall I need to execute this one and cross check? Java C buffer reader demo.java, control find, asking for an input, yes, working fine. Clear with the things. You can write it in a two different stages, no problem. In one stage you can create object of INS, then you can give that particular INS object as argument for your buffer reader. Can be done, no problem. So instead of writing in a two statements, I have combined that one and wrote in a single statement. Clear?
Yes, sir.
Maximum times you will be either using a scanner object or a buffered reader object. So whenever it is an operation with respect to strings, it is preferred to go with a buffered reader rather than a scanner. If you are working with a different data types like int, float, and all those things, where you have a frequency of a reading input a lot, so in only those cases, a scanner object will be preferred, right? If you are in the most of the cases, that means if you are working with respect to real-time applications, most of the times input will be taken as a string itself, so buffered readers will be used a lot when compared to scanners, right? So just continue with the PPT. So the same statements have been written with respect to PPT, and so means here you have a simple example where it is reading a both integer as well as a string, right? So like as already told you, if you are reading an integer, so you are performing integer dot parse int. That means read line will be taking this particular 50 is also a string value. Now I don't want to consider 50 as a string. I want to consider it as an integer. So I'm writing integer dot parse int. That means this 50 explicitly converted to an integer, right? So everything which has been read with respect to buffered reader, everything will be considered as a string itself. If you want to convert those things explicitly, then you need to use integer dot parse int, floating double dot parse float, double dot parse double, right? So you have to explicitly convert those things to a your specified data types. Clear? Right. So differences between a scanner and a buffer reader. So these I have already given a glimpse of these things. Buffered reader is a synchronous while scanner is not, right? So don't worry if you don't know what is a synchronous means. Buffered reader should be used if you are working with the multiple threads. I already told you if you have a multi-threading kind of a stuff, then buffered reader is preferred rather than a scanner one. Buffered reader has significantly larger buffer memory than a scanner. That means input you will be reading, right? So that input read will be stored in a some memory, right? If you are using a scanner object, then the memory will be a less. But if you are using a buffered reader object, then memory will be a more, right? So for a scanner, even though if you are saying a less, that is more than enough to store your input values. The scanner has a little buffer, that is 1 KB, that is a char buffer, as opposed to the means as compared to a buffer reader, so which will be having a 8 KB byte buffer, right? So but it is more than enough. You can read your different types of input within that particular space. Buffered reader is a bit faster as compared to a scanner, because scanner does parsing of a input data, but buffered reader simply reads a sequence of characters. Right? So I already told you, scanner, it will observe what kind of a data you are reading, whether you are reading an integer, double, what kind of stuff you are reading. So that will be observed with respect to scanner. But a buffered reader will not do all these things. Whatever input you will be giving, so everything will be considered as a string itself. Right? So these are the different ways of reading an input from the user in a Java. So means most commonly used ways, right? So if you have any questions with respect to any of these things, you can post those questions in a chat box. Sorry for the interruption. No questions in the chat box. So am I that much good in explaining the stuff? Right, and one more thing, I have not, so means we have not done a postmortem on these things. I just explained you what is a word. So you can, keeping this particular information in mind, you can check out a few examples on how to read different data, so means different types of data using these things, either a scanner or by buffered reader. Shall we proceed with our lab program? "76 participants today." Yes, so let us not waste much of a time. Let's quickly go to our lab program number 6. Right. So after seeing this particular program statement, you should be in a position to write a program. I'll be just explaining you what is, I mean, this program has got two parts. One part you should be aware of those things. Second part I will be explaining. What is that first part? What is that second part? Let us look at the statement. Right. So our program, so means experiment number 6 says that to implement linear queue using user defined exception handling. I think you came to know which is the first point, which is the second part now, right? So implementing a linear queue is the first part, correct? User defined exception handling is the second part. Clear? I said that this is my portion, that is exception handling. Linear queue is not my portion. This is your data structures. Clear? Anybody, can you give what is a queue? What is a linear queue? What are the different operations of a queue? What is queue? What approach used for the queue? What type of approach used with respect to queues? FIFO. First in, first out. Okay. Then what are the different collection of data in a sequence? FIFO. Right. So what are the different operations that you can do with respect to queue? Push, pop. Shubham is saying NQ, DQ, display. Right. So similar, NQ is nothing but pushing element, DQ is nothing but removing element, display is nothing but displaying the content. Okay. Good answers. Okay. So next question. If you want to include an element into the queue, right? So with respect to queue, you will be having two variables, right? One is a front and another one is a rear. Correct? Initially, front and a rear will be pointing to a same location. Initially, front and a rear will be pointing to a same location. Now, if you are inserting an element, which variable you need to increment? Whether you need to increment a rear or a front?
Sir, for the first value, we have to increment both.
For a first value, we have to increment both. Okay. So later?
Later only we have to increment the rear value, front one will be fixed.
Front one will be fixed. Okay. So in a simple statement, can I say every time you insert a variable, a rear value will be incremented?
Yes, sir, you can say.
Yes, can be said. Now, if you want to remove an element from the queue, which value? So means based on which particular value you will be removing the element?
From front.
From a front, right? So every time you insert a value, you need to increment your rear value. Every time you remove an element from a queue, you will be uh, taking out
Increment.
whatever is the content of a front, that you will be taking out.
Yes.
Correct? Yes. Clear with that? Okay. Now, with respect to conditions, what are the conditions I'm talking about? I'm talking about if I want to insert an element, what I need to check? I need to check whether queue is full or not. Correct? If a queue is full, I cannot insert an element. Clear? Right. So one more condition with respect to deleting element. While you are deleting element, you need to check that whether your queue is empty or what. Right? If your queue is empty, you cannot delete element from that particular queue. Clear? With respect to display method, what I need to remember? What I need to remember is whenever a display method has been called, from a point of a front till the point of a rear, whatever is the content that has to be displayed. Simple, right? Understood the basics of a NQ, DQ and the display now. Right? So clear with the conditions also. Right. So shall we start writing our user defined exception handling with respect to linear queue? Yes, I hope this much introduction or this much information about queues is more than enough to understand our program. Clear? Let us proceed with implementing our program. New share. Okay. Hope editor is visible. Yes, visible. So I have created a prototype of that. Lab program 6. Right. So few things will remain common. What are the few things is here also we need to see. I have given a hint here. See, huh. What are the things? What we have to do with respect to our program is we need to have a one class which implements all our linear. So means all our linear queue methods, right? So we need to have one class which implements all our linear queue methods, right? Along with that, it should also extend our exception class, right? So if it is extending our exception class, what does it will become? It will become our user defined exception class. Correct? Huh. Now what I'm saying is we need to have class linear queue, okay, extends our exception class, right? So once I am saying this particular statement, what we are doing is we are creating our user defined linear queue class. Correct? Now, with respect to this particular linear queue, I need to have a few constructors. One constructor is once I call that particular so means zero argument constructor. When I say zero argument constructor, front should have a some value and the rear should have a some value, right? So for that reason, initially I need to have those variables written. You need to have a variables, right? Front and the rear, and I need to have some array also. Correct? So let me create those instance variables. Front, not a dot, comma, rear. These are my instance variable. Later, I need to have something called as, I need to create an array actually. Array so means a linear queue, right? So some size array I need to have, right? So for that reason, so let me create one variable which I will make it as a final, right? So I will say final int size is equal to some 5, right? So now what is my intention is I need to have an array with a size of a 5. So let me create that particular array, right? So I name that one as a queue which is equal to, one second, which is equal to new int of whatever size you have specified. You can directly write int of this particular 5 also, no problem. But this is also one of a way. You will be comfortable with creating the final variable also. Let it be. Now, with respect to linear queue, I wanted to have a constructor, zero argument constructor. That means once object of a linear queue has been created, I need to have a variables declared something like this, right? So what is my intention is, initially I'll say front should be pointed with a 0 and a rear can be a 0, right? Initially both the things are pointing to a same location, right? So is it okay if I write a -1 also? You have a one array, zeroth location you have a friend, rear is pointing to a one location back to that particular friend. Can be done, no problem. But when you are inserting an element, you need to make a rear plus plus, then only you insert an element. No confusions, right? Yes. Now, whenever there is an error message, exception handling in the sense when there is an error, you have to display suitable message, right? So if you remember, we have written some user-defined class, then with respect to user-defined class, we have created a constructor which takes argument as a string, right? So we will create that particular constructor now, linear queue of which it takes a string as an argument. String, yes. Right. So what it has to do is whatever error message it get or it need to be displayed, so that it will call just a super, right? So who will print a error message for us now? Print stack trace. Where will be a print stack trace? It will be in a throwable class, right? So how this particular message will be given to a throwable class? Because it will be given because you are extending your exception class. Clear with the things? Clear with both the constructors?
Sir, explain linear queue once more, the super.
This one.
Yeah.
Were you, so means whether you were present for a customized exceptions class?
Yes, sir. Yes.
Too young, too old exception class.
Sir, what?
We have written a one class which is like a too young, too old classes.
Yeah.
1 second, I will show you that one. It will be clarified. 1 second. Okay. Huh. Here we wrote a one constructor like a too young exception, and we said the string a message, right? So message in the sense whatever error message you are creating. Say for example, if you are saying age is less than 18, you are throwing some information, right? So too young for a marriage.
Yes.
It means what a exception, what kind of a error message you wanted to display, that particular statement will be passed, right? So in a similar way we are writing here also with respect to linear queue. If you have got an error, so what kind of a message you wanted to display, so that particular error message will be carried in that particular constructor.
Okay, sir.
Hey, 1 second, I'm searching for it. Okay. So one constructor for reporting your error message, and another constructor is for initializing your variables of a front and a rear, right? So what else we require with respect to this one is we require three methods. One is a enqueue, and another one is a dequeue, and the third one is a display, right? So let us write those methods: enqueue, dequeue, and a display. Okay. So now I need to have a wide enqueue method, right? So let it take some int element. Okay. So this particular element I wanted to insert in a queue, right? So I cannot directly insert this particular element in a queue. I need to look at for a few conditions. So what a condition I'll be checking is, let me copy paste a few statements. That is not that much bigger statements. You can easily relate to that one. So I am very poor in writing that much bigger system.out.println statement. So I am copy pasting. So with respect to n key, what I am doing is I am just checking whether rear is equal to minus 1, right? Minus 1 in the sense just before my front. Okay. Or rear is less than or equal to less than a size minus 1. Size minus 1 in the sense last element, right? So your rear value should be lying in this particular position, right? So what I am doing is rear has been incremented. Rear will become a 0 now. So at a location 0, whatever element you have passed, that particular element will be placed, right? So once you place the element, you are writing system.out.println q, that means that particular element q has this particular element at this particular position. Any confusion? Say for example, if you are passing a 10, initially q is a empty. Q is empty. What are the values with respect to front and rear? Front is pointing to 0 and the rear is pointing to minus 1. Now you want to insert a 10 into the queue. Yes, 10 will be passed here to a ELE. Now you are checking whether rear is equal to minus 1. Yes, initially rear will be a minus 1. This is what we have specified here. Yes. Or another condition, rear is less than size minus 1. When you are writing OR condition, if a one condition is satisfied, it will go inside a for loop, inside a if statement. Correct? Because you are writing a OR, not AND. Right. So rear is equal to minus 1. That is enough. So it will go inside your if statement. Inside a if statement, what you have written? You have written a plus rear. Plus rear in the sense, now minus 1 will become a 0. Correct? At a location 0, q of 0, you are placing whatever element has been passed. You are placing whatever element has been passed. Now you are just printing the information, whatever the operation has been done, right? So what you are saying is, now your q has q of rear. That means what is the value of a rear now? 0. That means at a location of q of 0, whatever is the content. What is the content now? 10, right? Q has 10 at a position 0. This is what it will print, right? It will print q has 10 at POS 0. No confusions, right? Expecting response.
Sir, can't we use AND in place of OR? Will it give any error?
When you are using a AND, then it will check for both the conditions. That means
Yes,
both
sir.
the situations should be true, then only it will go further. See, what happens is, once you are inserting an element, rear will be incremented to 0.
Yes, sir.
When rear has become a 0, so 0 double equal to minus 1, it will become a false.
Okay.
When
Yes,
it
sir.
becomes a false, you cannot insert a further elements.
Yes, sir.
Okay.
Sir, why to use two conditions, sir? However, rear is less than size minus 1 is enough, right? Even minus 1 is less than size minus 1, right?
Rear is less than size minus 1 is enough actually. Instead of going with the two conditions, if you want to use only one condition, means you can use a rear is less than size minus 1. That is enough. Can be done.
Okay, sir, thanks.
Just for a security, safety we are writing to.
Okay, sir.
Sure. Now, with respect to NQ, this we need to assure. That means if a rear is a crossing a size, then an element should not be inserted. Correct? Now what I will do is, with respect to this statement, that means if this is not a proper scenario, that means if this is a true, then only element will be inserted, right? If this is not a true, then it has to print a else statement. 1 second, where if has been closed. Okay, so this is not a point of a closing for if statement, right? If has been closed now. Now what I have to do is, I will be writing a else part in the sense, if that is not the condition, I will be throwing a one exception saying that Q is full, right? So else throw new, what exception? Linear queue. This is what exception we have created, user defined exception, saying that is clear. Yes. Now can we do the similar things with respect to our DQ also? Yes. Here till this point everything is perfect, no need to worry about any of the statement. You have checked all the condition. If a condition is not true, you are throwing a suitable error message also, right? No problem with respect to these things. Now we can enclose these statements in a try catch block also. If you have any exception raised, if you have any problems with respect to this particular block, you can have a separate catch block written for this. Catch linear queue L. If there is any exception, then system dot out dot println of L dot get message. When I'm writing L dot get message, class name will not be specified, only the message, error message will be specified. Right. So this is your try block, catch block is done. Where I closed. Be clear with the closing. So this is a close of a try. After a catch, method has been closed. After a catch, method has been closed. Done. So I said already, in a similar way you can go with a DQ. So DQ in the sense you wanted to remove an element from the queue. So while going with respect to DQ, you will be checking whether my queue is empty or what, right? If it is empty, you cannot perform a deletion operation, right? If it is not empty, then only you can perform deletion operation, right? So void DQ, just writing a proper method names, NQDQ, right? Okay, so method, right? Why I'm doing syntax errors? Okay, so with respect to DQ, as we already said, we need to check whether our queue is empty or what. Okay, if not empty, then only we can delete the element. So I'll just copy paste those statements. One second. Similar to NQ, whatever we have done, same things with respect to DQ also. Within a try block, we are just checking whether front is less than a size, right? So if that is the case, then you are ready to take out element from your array. Okay, so wherever a front is pointing, so that particular element has been removed. So once you remove, so that element will be ready for display. That means deleted element is queue of front plus plus, right? So if a front is equal to size, what does it mean? If a front is equal to size means q is empty, right? Clear with the statements? Any confusions? right? See, I'm telling you, whatever the things we have done with respect to NQ, the same kind of stuff we have done with respect to DQ also. We have enclosed a condition within a try block. So after a try block, you are writing a catch block. After checking a condition, you wrote a else block. Else block, you are just checking whether it is empty or what. If it is empty, then you are making a front is equal to -1. Nothing more. Shall we go with the display method? Yes. Display method is also simple. First, we need to just cross check whether it is empty or what. So if it is not empty, then you have to start printing a content, right? So display method, if a friend is greater than -1, that means from a 0th location. So system.out.println elements are, right? So I'm just taking, this is my instance variable, so I'm just copying that particular instance variable into a some local variable k. So from that particular k, that means from a location front till a rear, from a location front till a rear, whatever is the elements with respect to k index, so everything will be displayed. Clear with the display method? So we just cross check what are the things we have done. Yes. Initially, whatever the statements we have, you have said, so the same things we have written. So initially we have taken a front is equal to 0 and the rear is equal to -1 and our queue size is a 5, right? So whenever an object of a linear queue has been created, front will be pointing to a 0 and the rear will be pointing to a -1. If there is an exception, when you are writing a throw new followed by linear queue, right? So that particular string will be given to a print stack trace for a printing. So this is the constructor for exception handling, right? So the next one is to insert an element into the queue, and the next, so means we need to implement 3 methods. One is to insert elements, next one is to remove elements, and the third one is to display the contents of your queue. Correct? So NQ means inserting elements. While inserting, you are just checking whether our rear value is within the range of our size or what. If it is within the range of a size, then you will be adding that particular input element into that particular position of a rear, right? If not the case, then you are throwing an exception saying that queue is full. That means if a rear is crossing a size, then you are saying that a queue is full. Now I cannot take elements, right? So this particular condition you are writing in a try catch block. So in a catch block, if there are any errors, that exceptions you are going to handle. Clear? We made a size as a fixed just not to make a program a bigger one. That's it. Or else you can read an input from a user based on an input only. You can have an array, so based on that particular array size only you can read a values. No problem in that, right? So similar things. So as I explained already, so I'm just scrolling down. So we have implemented a methods with respect to DQ and the display, right? So before you go to performing any operations with respect to a main method, so let us just cross check, are there any syntax errors with respect to this one? Java C lab program 6 dot Java. Yes, no errors. Now we can check with respect to adding a values, right? So I need to create object of a linear queue. Linear queue q is equal to new linear queue. Object has been created. So using the object QU, right? So NQ of some 10, right? So after this, shall I just check what is the content of a my queue. I'm just checking whether the things are working fine or not. What the kind of a spelling mistakes? Yes. I said a NQ of a 10, so it is saying a Q has a 10 at a position 0. The elements are, right? So I have a only element at 10 in my Q. Right, so it is working fine. So we will analyze our program a bit. Right, so let me copy paste a few statements. You need to be in a position to tell me what will be answer of those things. Yes, what will be answer till this point? What is the size of our queue? 10, 20, 30, 40, 50. Size is filled. If I am writing a queue dot display, will it display all 10, 20, 30, 40, 50 for me? Yes, it will display. Now, after this particular statement, can I go with one more NQ statement?
No, sir.
Ah, 1 second. Now, so I have already inserted a 50 elements. So displayed those particular elements and trying to trying to add a one more element. So now what will happen? What will happen is it will go to this particular condition of a NQ. So with respect to NQ, this particular condition will become a fail. So when this condition become a fail, it will go to throw new linear queue exception, which is called as queue is full. Right, so I need to get that particular statement which is called as queue is full. Getting right? Now can I add few more statements after this particular statement queue is full? After this, can I add a few more statements, DQ statements? Will it execute or will it stop my process of execution? Let us just check. Why to worry? Compile file. It has given you an exception saying that a queue is full. After throwing that particular exception, it is whatever instructions you have written later. So after that particular exception statement, so it is performing all those things. Element has been deleted is a 10, 20, 30. After deleting a 10, 20 and a 30, whatever remaining elements you have is just a 40 and a 50. Right, so once there is an exception, your program will not be terminated, so rather it will be something like whatever thing has to be done, you have written those things in the catch block. So 1 second, there are a few more statements. Yes, right, so previous display was till this point. Previous statement was till this point, so you were remaining with another two elements. I tried to remove those two elements also, right? After removing that, again if you want to remove, you were having only two elements. If you are trying to remove a third element also, when your queue is empty, so then also it will throw you a message saying that from an empty queue, you cannot delete elements. Complete output from here. 10, 20, 30, 40, 50 has been inserted. Those things has been displayed. After a queue is full, that means size of a queue was a 5, you have inserted a 5 elements. After a queue is full, if you want to insert a one more element, then it was a throwing you error saying that queue is a full, right? So when a queue was a full, you started removing the elements from the queue. First you have removed 3 elements and just checked what is the content of your queue now. 2 elements were remaining. That is output. 1 second. Oh, I didn't save this one. Compiled fine. Okay. It should go up now. Right. So these are the first 5 elements inserted, displayed. So when a queue is full, first 3 has been removed, 2 were remaining. Later again 2 were removed. So now the queue was empty. So with respect to empty queue, if you wanted to remove one more element, then it was showing the exception saying that no elements to delete. Right? So this is your exception handling with respect to static linear queue. Static in the sense you are initially specifying what is the size of a queue. You are not taking a value of a queue at a runtime. That means size of a queue you are not taking at a runtime. So it is static linear queue implementation with the exception handling. Hope it's a simple only. If you know how exactly the queues will work, I mean operations with respect to queues, means we have not done anything else. Just we have inserted some try catch blocks for those particular operations.
Sir,
Yes.
so once please show the output, sir. Sir, here in the output, elements are 40 and 50 it is displaying, right, sir? But we created array. The empty element should be displayed as 0, right?
Where is the empty element? See, you have a created array with this particular elements. 10, 20, 30, 40, 50. These are the elements with respect to array. So that is what it has displayed here. After this, you have removed only 3 elements. 2 elements are there still in a queue.
So want to show the other 3 elements as 0, sir?
Why it will show? When you have elements, why it will show it as a 0? Oh, you are saying the complete elements. So these 2 are the elements and the
Yeah,
remaining.
sir.
No. It will not show that kind of stuff. See how the things will work is, see, when you have an array, so now once you are removing the element means you are just incrementing your front value. Have a imagination. You have a queue, you have an array of 5 elements, 10, 20, 30, 40, 50, right? So now if you are removing a one element means you are incrementing your front value, right? So once a front is pointing to a 40th, that means at the index, so means what happens exactly means once you are removing a one element means front will be incremented, right? After displaying this particular value called a 10, front will become a 1, right? So when front is a 1, if you are removing one more element, front will be pointing to a 2 and this will be displayed for you. Right? So when a front become a one more time plus plus, that means one more time if you are removing the element, front will be incremented again. Now it will be pointing to, see, whichever element it is displaying, right? So after that your front will be pointing. After removing a 30, Now your friend will be pointing to a location 40. That means a location 3.
So means those values are in the array, but we are not displaying them, right, sir?
Yes, yes. They are in array, but you are displaying from a friend to rear. Wherever a friend is pointing, from that point to rear.
Yes, sir, got it.
Yeah. Any other questions? So again, things remains same. I don't know how many of you have submitted your previous lab experiment in a Google Classroom. If not submitted, submit it as early as possible. And this also, after this particular class, after 15 minutes, I'll be getting a recording of this. I will share your recording. If you have any doubts, go through the recording. If you want to try the program, do a trial and error methods. Understand a program thoroughly, then only prepare a report and upload. Why am I saying is, as soon as I create assignment in a Google Classroom, within a 5 minutes, I'm getting a report in a Google Classroom. I don't know. Some people might be just copying this particular document and just taking a screenshot of that and pasting in the same document and maybe uploading. But don't do like that. So this is for your purpose itself. Take us some time, analyze the things, understand the things, then only prepare a report. Right? So that's it from my side.